Hello, this is mathjazz from Almost Cool. This is the 11th video in our series of videos on derivatives. Our topic today is logarithmic differentiation. Logarithmic differentiation says that if we take the natural log of a function and then take the derivative of the resulting function, we get the derivative of the original function divided by the original function. Equivalently, we get that the derivative of our original function is equal to the derivative of the natural log of the function times the function. We obtain this from the previous equation by multiplying on both sides of the equation by f of x. This may not seem more than applying the chain rule to the derivative of the natural log, and you'd be right, that's exactly what this is. However, this allows us to simplify derivatives of complicated products and quotients using logarithm rules. Let's see an example. We're going to find the derivative of f of x when f of x equals x to the 3/5 power times sine of x times the third root of 1 minus x squared. Notice that this is indeed a product, and we could use the product rule. However, since there are three different terms being multiplied together in this product, we would either have to use the product rule on two of the terms and the third term with the other two terms, or we'd have to use a three-way product rule, which does exist, and we might bring that up in another video. However, we could use logarithm rules to simplify this product because the log of a product is equal to the sum of logarithms, and derivatives are linear. Basically, logarithmic differentiation is a way of turning multiplication into addition so that we can use our derivative rules on each different term in the sum. So, we start by taking the log of both sides. Using our logarithm rules, we can split the log of the right-hand side of the expression into the sum of three separate logs, and it doesn't look like it's a lot less complicated yet, but we'll continue to use some log rules, taking our 3/5 power as a coefficient and our 1/3 power as a coefficient of the respective natural logs. From here, we're going to take the log of both sides of the equation. It's just implicit differentiation. We get f prime of x over f of x equals 3/5 times 1 over x, because 1 over x is the derivative of the natural log, plus cosine of x over sine of x, because the derivative of sine is cosine, and the derivative of the natural log of some function is the derivative of that function divided by the original function. Ergo, we have cosine of x is the derivative on the top of the fraction, and sine of x is the original function, and it's in the denominator. Then, taking the derivative of the last term, we get 1/3 times negative 2x over 1 minus x squared. Again, the original function, 1 minus x squared, is in the denominator. The derivative of that function, negative 2x, is in the numerator. Now, to solve for f prime of x, we just have to multiply both sides of the equation by f of x. And f of x is what we started with at the top of this list of equalities. So when we substitute in the formula for f of x, we get that f prime of x equals the product of 3 over 5x plus cosine of x over sine x plus 1/3 times negative 2x over 1 minus x squared, and then all of that times x to the 3/5 power times sine of x times the third root of 1 minus x squared. And this was easier to do than using a three-way product rule. Or even if this wasn't, there are examples where you have enough items being multiplied together where the natural log or logarithmic differentiation would make it easier to take the derivative of. So we'll see another example. Here we have a product in the numerator and we have a quotient in the function. So to do this using our other derivative rules, we would need to use the product rule and the quotient rule in the solution of this problem. However, division becomes subtraction when we take the log of both sides of this function, so we're going to use logarithmic differentiation instead of the product rule and the quotient rule. We take the log of both sides. We simplify our logarithm on the right-hand side of the equation. All of the powers become coefficients. And then we take the derivative of both sides of the equation. F prime of x over f of x equals 3 over 5x plus cosine of x over sine x minus 1/3 times negative 2x over 1 minus x squared. We multiply on both sides of the equation by f of x, and when we substitute our original formula, or our expression, for f of x, we get this. F prime of x equals the quantity 3 over 5x plus cosine of x over sine x minus 1/3 times negative 2x over 1 minus x squared, whole quantity multiplied by x to the 3/5 times sine of x over the third root of 1 minus x squared. And this was probably easier than doing a quotient rule and a product rule. Thank you for watching this video. My email address is listed on this page, as is the website and Facebook page of Almost Cool. Feel free to email suggestions, ask questions, list errors, or suggest topics for future videos by going to any of these three channels of communication. I hope that you're enjoying learning calculus. I am enjoying making these videos. Have a great day. Goodbye.